Welcome to F Sharp Fun and Games, as I decided to call it. First, a bit about me. My name's Anthony. I'm a third-year undergrad in electronics at the University of Southampton, but I also run and develop games for Blue Yolk Studios, which is independent game and app business. So, this talk, well, it's about three key things, really. First up, what is F Sharp? So, for those who don't know, I'll go into a bit of detail about the language. Introduce game development using .NET technologies a bit as well, and then show you some examples of why you should combine them and why you get really nice, cool results out. So, first up, what is F Sharp? Anybody used F Sharp? Hey, that's some people at least. For those that don't know, F Sharp is a strongly statically typed, multi-paradigm, strictly evaluated, open source, high-level programming language from Microsoft that runs on the .NET framework. Yeah. Essentially, it's Microsoft's attempt at a functional-first programming language. And it's really nice because it runs, oh, we'll come to the reasons why in a minute, but it's also .NET, so interfaces with everything, C#, and if you must, VB. So, a couple of things about F Sharp. It's essentially, like I say, open source. Compiler itself is entirely open source, and it's available on all platforms that Mono's supported on, which is an awful lot. But anyway, onto the gaming side of things. So, Bastion, Fez, Terraria, Magica, they all have one thing in common, which is they were all written in XNA. Now, some of you might remember the retro games console that is the Xbox 360. Microsoft released an independent game developer program on there called Xbox Live Indie Games. And along with that, they released a game framework called XNA. And XNA was brilliant, and it led to brilliant games like these. But Microsoft killed XNA. So somebody decided that they wanted to run XNA games on their iPhone. And hence came along Monogame. So Monogame is essentially an open source cross-platform implementation of XNA. When I say cross-platform, I really do mean cross-platform. Windows Phone 8, Windows 8 App Store, Windows Desktop in either OpenGL or DirectX flavors, Android, iOS, Ouya, Mac OS X, PlayStation Vita, PlayStation 4, and who knows where next. Now, it's a really nice level of abstraction on top of the likes of OpenGL and DirectX, because if you've ever had to deal with those, it's a lot of code to draw a triangle, like a lot of code. But Monogame makes it simple. You know, let text equal content.load texture2D player. I can instantly see, and Monogame handles all of the cross-platform issues with loading content from a file stream. And it's just really nice. Same with the drawing side of things. Just a single call to draw with my texture, and everything appears on screen where it should, most of the time. Now, a lot of people, say, why .NET for games? But .NET's actually really popular. But, you don't have many choices for frameworks. Key ones that you've got are DirectX and OpenGL, but it's a lot of code. SpriteKit on iOS, but it's very platform dependent. Unity, if you like being stuck in .NET 2 and 3.5 land, which I don't. And, well, I've just heard of another one called Duality, which is supposed to be nice, but I've not heard of it, so can't comment on it. And XNA. So why put F Sharp with XNA, or in this case, Monogame? So first thing is, confession from me. I really just wanted to play with F Sharp. Local developer user group. All of a sudden, you've got one person who uses F Sharp, and all you hear is, could do that in 5 lines of F#. All that code he's got. Look, it's 10 files there. It's 5 lines. But since then, I've started to notice a lot more sort of things which make it a lot nicer to work with. So, first one is speed. Now, when I say speed, I kind of mean 2 types of speed. You've got the speed of how it runs. You know, it's fast. It's .NET, so I say fast, it's fast enough for most cases. But also speed of development, which we'll come to later. You know, it's a lot less code for a lot more happening, I'll say. Also, it runs everywhere. Now, it needs .NET 4, so it doesn't run on certain things that Monogame runs on. So you're not going to get PlayStation Vita support, unfortunately. And yeah, so like I say, I've seen people running F# on iOS phones, Android phones, Raspberry Pis. I think somebody's even started running it on small embedded devices that can run the Mono framework. And there's also this chap called John Carmack. Some of you might have heard of him. He made some games which were quite popular or something. But he spent his QuakeCon keynote this year, and he spent about 30 minutes saying how brilliant, you know, these functional languages were for game development. And you know, he was there. He spent a week porting the original Quake to Haskell, and he said, you know, it's so much nicer and so much smaller. He said, I think he went from about 10,000 line code base to about 1,000. You know, it's ridiculous compression. But the key point for me is that it's effectively eliminated the need for prototyping. So with games, you're dealing with a really abstract concept that is fun. What's fun to me is probably not fun to some of you. But the normal way of testing this is I'd go out, I'd pick up something like Python or JavaScript or any other languages like that, and I'd make a prototype. And then I'd show it to a bunch of people, and they'd all tell me, what are you thinking? That's terrible, or why is this not on the App Store yet? So I've then got that, and it's out in public. And I've then got to go back, and I've got to port it to either the individual platforms or try and make some cross-platform solution, in which time an unscrupulous company with certain history of stealing games from small independent developers to benefit their own goods, I'm not going to name names, comes out with their own version. They've got a massive player base, so theirs gets all the exposure. The indie game goes down. Whereas if you've got something which can run pretty much anywhere, anytime, fast enough, and actually you can develop quick enough then you can get rid of the need for prototyping. You know, I've got my prototype, that'll do, get it out. We'll see. People might like it, people might hate it, but it's the same amount of time I've spent making my prototype, so why not go for it? And so with that, I think it's demo time. Now, some of these demos have been targeted to C# developers, so you can see their minds being blown when you go through them, but it might not be as big to some of you. So the first one, making a platformer. A couple of months back, I was at a game jam, and there was a team of 5 of us. You know, we're all decent C# developers. There was a VB developer and an F# developer. So the F# developer goes out and says, let's make it in F#. To which he hears, you've got to be kidding, haven't you? Got to be kidding. But he wasn't kidding. So we made it in C#. And it took a team of 5 people a day to get the platformer mechanics working. It's kind of a long time, really, for what it is. And it was a lot of code for what it is. And you don't want to have to spend all your time writing code. I want to see results. So I went home and I thought, these guys, they got it all wrong. I'm going to do it in F#. I'm going to show them. So I did. Took me 4 hours, afternoon, on my own. Sat down, blitzed it out, and it exhibited all the same mechanics. You know, I'd managed to get all the stuff that we got in that day done in 4 hours in a lot less code. I mean, it was 400 lines of code for my mechanics. C# version, 1,000 lines of code.
What was the thought process like when you were translating to abstract? Were you doing a translation, or were you actually changing the way it worked based on the fact that you had new abstractions to work with?
So did I change it as in the abstractions? So
Conceptually, how it was working in C#, is that conceptually how it worked in abstract as well, or did you make some changes based on the fact that you were the function paradigm?
well, I'm just about to go through and show you, so hopefully should explain. But yeah, so, and the amount of files as well. You know, the F# version is about 6 files. I could instantly see pretty much my entire code base. C# version's in about 30 or 40 files. And that's got multiple interface definitions in certain ones as well. So you just get lost in this mass of blah that's also called brackets, I think. So, let's first take a look at the results of the, not that one, that one, at the results of the C# version. So let's build. Yeah, I have to show that because if you do have epilepsy, don't watch. It was a game jam, remember. Bear that in mind. It was a game jam. So, you know, basic platform and mechanics. And it's a lot of code. I mean, things like map object wrapper icollidable. There's a lot of icollidables, and I can't really see much about them. So I then went and did it in F#. You know, this is just the basic platform and mechanics. This wasn't a full rewrite of the game. So we can have a look, and we'll see. Look, it's flying. And, you know, we've got the mechanics there. Like I say, it's not a fully fleshed out game, but it's got the basis of being a game. And it's a lot less code, and it's a lot more readable. If you think back to the keynote this morning, you know, one of the key paradigms, or one of the key features of functional languages is it's just a transformation. If I stand here and I jump, you'll see that I can go through the process, and I was moving up, gravity took its effect, I moved down. So we can think about that, and if we look here, you know, we can sort of see, we're taking all of our objects in the world, and we're going to see, did the user interact with them? No. Does gravity affect them? No. We'll add friction to make it more like a realistic model. We'll handle collisions in case somebody's decided to run into the world. Then we'll update all our animations and stuff. And it just, that is essentially everything that happens in a game loop. And it's readable. I can see that and instantly see that's everything that's happening. And in my opinion, that is a lot easier and a lot less hassle if I was jumping into it for the first time. So, next feature. REPL, read, eval, print, loop, etc., etc. Essentially, whilst F# is a compiled language, you do get interactive elements with it as well. So, imagine you're making a level for a game, and it's a platformer game. And I've got a platform which I can't quite reach. Normal process would be, I'd open my level editor, change the file, reload the game, run back to the point that I wanted to test, and then realize I hadn't quite moved it enough. So I'd go back to my level editor, change the things again, realize I still hadn't changed it enough. And I'd keep repeating this, and you end up losing a lot of time. But with F#, I can essentially say, let's load in all of my game. And we do get, Visual Studio and IntelliSense as we're writing everything. So it makes it a nice experience as well. Let's create my game and create a few variables as well. And we've got a window open. Doesn't look like a lot yet. But I can just do things like, let's add to all of the objects that are in the world. And if we go back, I can now go, ta-da! We've got 2 people extra in there. We've dynamically changed the loaded assembly. And that's good, because it means I can spend time changing what I need to change and not having to sit there waiting while Visual Studio compiles my solution. And obviously, it's a full REPL as well. So we can do full expressions. We can do for loops. We can do, we can use the advanced F# features that we might not use before. So let's do this, and let's see what happens. Because I bet it'll be something good. And ta-da! 6 more people. Now, imagine if that was my level, and I decided, actually, we can edit this in real time. And it makes it so much nicer as a workflow without having to spend all of your time waiting and having to do these switches between dotting around on the internet whilst you wait for it to compile, to go back to, there we go. It's a nice feeling to work with. But also, our F# interactive window, we can embed it into applications as well. If any of you have played Quake, you'll know that you get the console in Quake, and you can type in commands that make you do crazy stuff and enhance the game further. Imagine if you could put that in your game. So you've got the full F# language within your game. And then just the amount of options that you've got available there to you to enable your users to get this really nice experience when playing. It's a lot better. Now, the next thing is type abbreviations. It's something really boring, but it's something that so many languages get wrong. I'm sure if you've ever used C# and you've seen the horrendously long namespace and class names that you can get, you'll have at some point thought using X equals hideously long class name. But that using X only relates to the file that it's in. F#, if I've got this, that says nothing to me at all. Rocketman of int, string. I reckon, as a decent shout, that's number of limes he can carry on a Sunday, times by his age, times by his mother's maiden name, times by his password. I think that's the best guess I can provide in a situation like that, given the context. But I can redefine types, and just type health equals int, and lives equals int, and so much time saving. And then I come to this and see that my original guess was completely wrong. But I've got that context now, and I can see, so he's actually probably an enemy who I can kill, and who can probably kill me, and who interacts because he's got a catchphrase, and he's got a name, so we'll see him. And we get full Visual Studio autocomplete as well. So here we go. if I run that, you'll see we've got snail of health times speed. Yeah. But now, if we run this, it fails. And it fails in a nice way, because it tells me it wanted a name. But 52 isn't a name. It's a number. So it tells me, don't be stupid. Think. And I get all this at compile time. Even though that's running dynamically, dynamically, it's being compiled. So the F# compiler is telling me, don't do that. Think about what you're doing and look at your mistakes. So I even get things like the autocomplete on pattern matching as well. So if I hover over, look, it tells me there. It automatically tells me that it's a type with this, this, and this. And the this, and this are something meaningful.
As you define your types, how was both the int and name speed both I guess they're not both straight, but because you have abbreviations, does this mess up your type difference later in your programming?
No.
When I'm doing this, I always have to, my type difference is a little bit broken. When I create an int somewhere else, it's like, oh, you have a type help, and you wanted to type int. You don't find that?
No, I've not found that at all. So, can't guess why to do that either. Right.
Sorry, just to jump in there, that obviously helps you if you transpose those two arguments. If you transpose the 52 and the 100,
Yeah, then it's going to accept that that's the issue here. But the main point is it's not going to blow up as a problem. You know, if I was writing this in Python and I gave it as those arguments, it's going to blow up and I'm going to end up spending a lot of time going through my code and trying to find it. And it means that I've got to do a lot more sort of actual testing of the thing. The compiler can do most of my stuff. I've not got to worry about as much the testing as much. Obviously, it's still something that you've got to look into, but... So this next one. Units of measure. Right. This function, what does it move and by how much? I don't know. Let's say that this is in my library somewhere. And I said, X is my position along here, and Y is how far along I am, or how far along I want to move. Now, that could be in meters, in which case, if it was in my physics engine, I could move this much. It could be a pixel, so I move this much. It could be, if I'm down at the really low level, things like device-independent coordinates, where if I moved one, I move half the size of the screen. No, full size of the screen, device-independent. If I'm down to device-dependent, one moves half the size of the screen. It gives me no clue as to what's happening and could lead to some crazy bugs. Now, I could say, let move meters x, y, and I know that it's going to be moving in meters. Compiler doesn't know that, though. So I've got to then look for it. But F#, I can say that a meter is a measure. So it's sort of, the compiler will say, and we'll come to this in a minute, it will say, that's not right. You tried to give me a pixel, and I wanted it to be a meter. So now, if I was to say, move it by 5 pixels, it's going to fail. And it's going to tell me that at compile time, rather than halfway through my code base going, it's not moved, but it has moved. I just can't see it. So, let's take a look at quick look at the demo. So here we go. I've got X, which is 10 meters. And then up here I've said that it's 10 pixels per meter. totally acceptable thing to say, and saying, to convert that back into pixels, I've done my calculation, and I've got 100 pixels. So now, I've also got a function called move. Let's run this. Now move accepts 2 meter types. So if I now go move x in pixels, zoom in and run it, and run it, it says, I wanted a meter, but you give me a pixel, and that won't work. So give me an actual measurement that you want. Now, units of measure are a compile time only thing. So at runtime, you won't be able to say, is this a meter or is this a pixel? It's just a compiler thing to make your life a lot less stressful. Right, computation expressions. This is a good one. If you've used F#, you've probably used one so far. If you've made a sequence, you've probably written something like, for x in 1 to 10, do yield x, and you've got a sequence of 1 to 10. But these things, you can expand them, and you can make your own. So here we go, here's an example. I want to write some logging code, but I only want to log after certain things have been assigned to. Right. Now, I could write that, but what if I forgot to write the log somewhere? It's not much use. But I can bind functions or I can add functions into the bind. And I can say, oh, you've bound a value to x. I'm going to log x. Leave out y, because I don't want to log y. But you want to log z. So I'll print out what you've written there. Now, if you've written games, you've probably ended up with something like this for your AI. And it ends up getting really complicated. I was speaking to a ex-game developer recently, and he said that about 15 years ago now, he was working on a game. And for their AI code, they'd got a switch statement that was a bit bigger than that, like 2,000 cases bigger than that. Now, as you're a game developer, you're probably not going to be designing your game because it's not what you want to spend your time doing. So you hand it off to the people that are good at it, who know what fun is, supposedly. Except, if I'd got 2,000 cases, and I was a game designer, and don't know how to code, I'm probably not going to want to fix it or change it. But imagine if I could write something so simple and readable that anybody could write it. Like that. You can instantly see what's going on there. Move 10, get the player out of the world, find the player, and then chase the player. F# computation expressions, you can add in extra functions that you want. And the best thing is, once again, we get full compiler support. So, if I was to do something silly, like passing a string here, it'd tell me, I didn't want a string, I wanted a number. Now, imagine if you gave this to your designer, yeah? And your designer's writing your game. Normally, he'd probably be writing it in something like Lua, which is, a brilliant language, but it's not got this type checking and nice things like that. So you get errors that fail at runtime, and it's just not nice. But here, we've got it telling me in Visual Studio before it even compiles, that's wrong, it's going to not work. You're going to need to fix it. So I can go back to my designer and say, look, mate, it's not working, can you fix it? And he can open it up and say, oh, yeah, that was meant to be 16. It saves a lot of hassle, and it means that we get a lot less bugs in our code when it's been shipped, and users manage to break it in new and interesting ways that we never thought of before. Like, why were you running into that wall all day? Why? So, I can see that some of you are excited by F#. Some of you. And it looks like there's something you want to use more and more, and make games and send them out to the world and see what you can actually make with them. fsharp.org/apps and games. That's your best resource. That's like the F# Software Foundation, which has been founded to try and make F# as brilliant as it is and make it better. It's a load of links to blog posts, to videos, to everything that you need to try and help you get your things out there and using F# in the best possible way. Monogame.net/documentation. That's the library that I've used, the framework. It's brilliantly easy to use. It's so simple. I mean, it's just initialize, load, update, draw, done. It'll do update, it'll do draw automatically for every time. And it runs everywhere. It's brilliant. Now my brownbrown.wordpress.com, that's my blog for F# for games. There's things like writing the platformer, how I went about it, how you can make it better. GitHub, that's the entire repository. It's there, it's available, do what you like with it. User groups, there's a lot. Look, we're here. Look how many there are. There's lots of people that want to use it. In fact, there's a user group in London, right here. Not right here, it's over at Skills Matter, but it's London, so it's here. It's the same city, right? Functional Londoners, Meetup. There's loads on Meetup. Look at all the ones in New York and America. It's brilliant. Go along, meet like-minded people. It's a brilliant language, and people need to use it more. Thank you. Any questions?
What are you drinking? Can I have some?
I'm drinking the Kool-Aid that Microsoft are providing with F#. It's apparently got a lot of sugar in. Any other?
Similar question to one I've posed before on F#. What's the tools like in Linux/macOS, the mono platform, the IDEs? How do you find those?
Mac is...
Could you repeat the question?
Yeah. So what's the tooling like on Linux and Mac and other operating systems apart from Windows? So there's a company called Xamarin, and they're a brilliant, brilliant company. They've got .NET working on like every platform you can imagine. And they came out with an IDE called Xamarin Studio, and it's really good.
How does it compare to Visual Studio?
It's pretty much Visual Studio, but you don't get plugin support, so you can't use things like ReSharper, but you wouldn't want to anyway because it's useless in F#. Linux, you've got MonoDevelop, which is still good, but it's not as good because Xamarin have pumped a lot of money into making MonoDevelop as good as they can for Xamarin Studio.
Didn't they include also the 4.0 version? I think they pushed it, so someone in Linux needs to scrap the changes.
Right.
So are they on 2 point something, or are they 4 point something on Linux, or
I'm not entirely sure. I'm not a mainly Linux user. But yeah, I mean, the tooling is still there. The F# compiler, like I say, is completely open source. The F# compiler that you use on Linux is the same as the F# compiler that you use on Mac and the same as you use on Windows. It's the same experience. You're not a second-rate customer. There's F# bindings for every editor, or most editors you can imagine. I'm sure people have got obscure ones. There's bindings for MonoDevelop, Emacs, Sublime. They're just off the top of my head. There's probably more.
Have you used the Sublime one? Can you comment?
Oh, I've not. No, I'm mainly Visual Studio, but I know I've seen it being used, and it looks to be a pretty good experience. Any other questions? No? Cool.
Thank you so much.